Okay, welcome back. This is solving systems of equations with the substitution method. Method number 2, the substitution. This is algebraic. The first one was graphically. This is algebraic. We're doing moving variables around and stuff. And I think you'll find this easier. I like this one a lot better. Much easier to get the exact solutions. It just makes more sense. And here's the steps. And I know you guys like it when you have steps to follow. You do one step at a time. So isolate any variable, the easiest variable to isolate. That's what you want to do first from either of the two equations. Plug the value of that variable into the other equation and solve. Plug the new value into the simplest equation and solve. So as I go through this, I'll show you the steps. Here's my system. I have 2x minus y equals 6, x equals y plus 2. One thing that's good about this particular system is you always want to choose the easiest variable to isolate. Well, if you look at this x is already isolated. So what we're going to do, since x is equal to this y plus 2, I can substitute, I can plug in this value into this other equation, which is the second step, right? X is equal to y plus 2. I'm going to replace this x with y plus 2. So I have 2. And instead of x, I have y plus 2 minus y equals 6. See, when you have one equation with two variables, you can't get a solution for a number. But now, by doing what I just did, by substituting, I now have only y's I can solve. I can find the number that y is equal to. So we'll follow our steps. We'll distribute 2y plus 4 minus y equals 6. And then I'll combine 2y minus y to get y plus 4 equals 6. And we'll subtract 4, and y equals 2. Okay. Now I know what y is equal to. And the last thing it says, plug the new value into the simplest equation. Well, if you look at our two equations, I feel like this one looks simpler. I mean, you could plug it into either. It will work out eventually. But why not take the easiest path? So if I take this y, put it right in there, my x will equal 2 plus 2, so x equals 4. Okay? All right. I'm going to erase, and I would like you just to try one. No, let's do one together. All right. Let's take this one from the book. Okay, I'm going to erase this here because this one's going to take a little more work, and we have these steps down by now. Okay. So the first thing that we want to do, we want to get any variable isolated. So like, you could solve for this x, but you would have to subtract 2y, divide by 3. You would have a fractional mess. It takes some practice to find out which variable is the easiest to solve for. What I like is this y right here. I like maybe this y looks like it's good to solve for because there's no numbers in front of it. So if I just add y to the right side, and then I would get 4x equals y minus 1. And then I would, let's see, I would add 1 to both sides. And ultimately I get y equals 4x plus 1. There we go. Now, this equation here, that I put a star at next to, is the same as this equation here, but I modified it so that y is now isolated. And y is equal to 4x plus 1. So now I can take this 4x plus 1 and put it into this other equation here. And if I did that, it would be 3x plus 2 times 4x plus 1 equals 13. I want you to notice the only difference between the very first equation, 3x plus 2y equals 13, and this new equation is that instead of the y, I substitute it with 4x plus 1. And I can do that because I found that y equals 4x plus 1. So now I'm going to distribute and solve for x. So 3x plus 8x plus 2 equals 13. And then if I combine the 3x and the 8x, I get 11x plus 2 equals 13. And then if I subtract 2, I get 11x equals 11. Divide by 11, and x equals 1. All right, now I know x equals 1. I can pick the simplest of all the equations. I can pick the simplest of any of the equations. So I could pick this one. I like that one because everything's positive. I could pick this one. I don't really think I like that one. But I can also pick this one down here and plug in x equals 1, so I could plug in 1. The reason I like this one the most is because the y term is already isolated. So I can say y is equal to 4 times 1 plus 1. And then y would equal 5. And so I didn't mention this in the first example, but look, this is a great way to display the answer. X equals 1, y equals 5. But another great way to display the answer is an ordered pair, or a coordinate, or a point. Because who remembers what happens at the point that's the solution for a system of equation of two lines? These are two lines. That's the point where the two lines intersect. So I love the answer as an ordered pair. This is a great way to put the answer, but you'll see the answer as an ordered pair a lot. All right, thank you so much. So we're going to practice some substitution, and we have another method.